This is the King Tiger. It was arguably one of the most powerful German tanks of World War II. As the successor to the Tiger I, it was designed to serve as a spearhead tank for offensive operations. While it was an awe-inspiring design, it was not as successful on the battlefield as its designers and the German leaders had hoped. We've modeled the King Tiger in intricate detail to showcase both the features that made it legendary and the flaws that led to its downfall. In this video, we focused on the most widely produced model, the Henschel turret version. My name is David Webb, and this is Blue Paw Print. The King Tiger was a massive vehicle, significantly larger than its Allied heavy tank counterparts, such as the M26 Pershing and the IS-2. The King Tiger's hull was 25 feet long, increasing to 33 feet 9 inches, with the main gun barrel at full forward position. The tank was 12 feet 3 inches wide and 10 feet 2 inches tall. The King Tiger was also by far the heaviest standard-produced tank of World War II. Its combat-ready weight was 154,000 pounds. The crew of the King Tiger consisted of 5 men. The commander sat at the rear left of the turret, directly behind the gunner, who was positioned at the front left next to the main gun. The loader was opposite the gunner on the front right side of the turret. In the hull, the radio operator sat at the front right, while the driver was seated at the front left. The King Tiger's armament consisted of a primary weapon, the 88mm Kampfwagenkanone 43L71, and 2 7.92mm machine guns as secondary weapons. Though used on other vehicles, the 88mm gun was the King Tiger's signature weapon. Originally designed as an anti-aircraft gun, the 88mm gun proved its worth against Allied and Soviet tanks in the early stages of the war. As such, it became one of the main reasons for creating the Tiger tank series. Due to its smaller size, the Tiger I was equipped with the smaller, less powerful version of the gun. The King Tiger was large enough to carry the weapon in its original size, which had a significantly superior muzzle velocity. The gun had a barrel length of 20.5 feet and a caliber of 88mm. The 88mm gun had to undergo a series of modifications to be used as a tank weapon. A muzzle brake was added, redirecting gases to the side of the barrel to dampen the recoil. Air was also blasted through the barrel to clear fumes after firing. Another significant modification included a pair of shorter, fatter recoil cylinders mounted just above the gun barrel. The right cylinder, a hydraulic recoil control cylinder, was designed to provide maximum shock absorption when fired. The cylinder on the left was hydropneumatic and built in 2 sections, a gas and a liquid section. The gas section of the cylinder brought the long, heavy barrel back to its original position, while the liquid section ensured this movement was done smoothly and safely. If the tank had to be abandoned, the crew could drain these cylinders and fire the main gun. This would cause the gun to recoil forcefully into the back of the turret, rendering it inoperable. The King Tiger's 88mm gun was undoubtedly the most powerful tank gun of the war, capable of firing projectiles at high muzzle velocities ranging from 1,968 feet per second to 3,707 feet per second, depending on the type of ammunition used. Trials showed that the King Tiger was capable of hitting a target with 100% accuracy at distances of 1,093 yards. At a range of 2.1 miles, the accuracy was reduced to 50%, which was still an impressive feat. In actual combat scenarios, these accuracy percentages were generally lower due to range estimation errors, environmental conditions, and battlefield stress. Oberstleutnant Alfred Rubel said, T-34 and T-43 tanks could be knocked out in favorable firing conditions at ranges of up to 3,000 meters. frequently as in the West, the Russian tanks avoided combating Tigers or turned away after the first tank was knocked out. The Tiger II has proven itself in every way and is a weapon the enemy fears. Some historians argue that the gun was too powerful for the targets it was designed to overcome. Its incredible size caused extended reload times and reduced ammunition capacity, both significant drawbacks when in the field. The King Tiger used two types of armor-piercing shells. Its primary round was the Panzergranate 3943. This round was specifically designed to handle the 88mm gun's high internal barrel pressures. The projectile featured an armor-piercing cap designed to penetrate sloped armor by reducing deflection upon impact. A ballistic cap placed over this armor-piercing cap enhanced the shell's aerodynamic performance, improving its speed and accuracy at longer distances. The shell also had a tracer and driving bands for added stability and accuracy. After loading the Panzergranate 3943, the gunner would electrically trigger the charge using a lever. An emergency button provided a failsafe in the event that the lever failed. When fired, the projectile traveled through a rifled barrel. The shell's two smooth driving bands were made of soft metal and tightly fit to the barrel walls, causing the barrel's rifling to spin the round. Though this increased the King Tiger's accuracy, it also caused increased wear on the barrel. Upon exiting the barrel, the Panzergranate 3943 accelerated to 3,340 feet per second. The tracer at the bottom of the projectile burned with a bright-colored light, allowing the crew to see the projectile's trajectory so they could adjust the aim for the next round. Upon hitting the enemy armor, the ballistic cap would split, making way for the armor-piercing cap underneath. This armor-piercing cap was made of a softer metal, flattening as it struck the armor, sticking to the enemy tank and preventing it from ricocheting while allowing the projectile to penetrate the enemy armor. This design allowed the Panzergranate 3943 to penetrate armor up to 8.6 inches thick at a distance of 550 yards. Immediately after penetrating the armor, a detonator in the bottom of the projectile would be triggered. A small charge of amatol would explode the projectile from the inside, providing maximum damage within the enemy tank. Against more heavily armored enemy vehicles, King Tiger crews used another type of shell, the Panzergranate 4043. The design of this high-velocity type of shell included a tungsten carbide core, allowing it to pierce up to 9.9 inches of armor at 550 yards. However, since tungsten was scarce, crews rarely used this shell. To aim, the gunner used the TZF-9D, a monocular telescopic sight mounted on the front section of the turret. The TZF-9D had a dual magnification system with levels of 2.5x and 5x, allowing gunners to switch between wider fields of view for target acquisition and higher magnification for precise aiming. A marked reticle assisted with range estimation and target lead. An outer dial was used for the range setting with 4 separate scales for each shell type. The tip of the reticle's centered triangle marked the desired point of impact. The small triangles on the left and right were used for moving targets. However, they could also be used to measure range. The heights and widths of the triangles, as well as the spaces between them, were expressed in milliradians. A milliradian covered 1 meter at 1,000 meters, or 50 centimeters at 500 meters. With these triangles and with the gunner's knowledge of the size of the enemy vehicles, they could calculate the range. For example, if a T-34 tank in the side view filled 10 milliradians in the sight, that would mean it was at a distance of 0.41 miles. The King Tiger was equipped with 2 7.92mm MG-34 machine guns. The first was a coaxial machine gun mounted alongside the main gun in the turret. It was operated by the gunner using a special pedal and shared the same sight as the main gun. The machine gun was fitted with a brass catcher to prevent casings from dropping on the floor by directing the spent ammunition into a bin. The radio operator used a second MG-34 mounted on a ball mount on the front right part of the hull. In addition to using his hands, the radio operator could aim the gun using a special metal half dome attached to the machine gun. By placing his head into the dome, he could guide the machine gun through his head and body movement. The King Tiger was also equipped with a grenade launcher, the Nahverteidigungswaffe, or close-range defense weapon. This spring-loaded launcher was mounted on the turret roof and could be operated from within the turret. It was designed for firing various types of ammunition, including smoke grenades for concealment, flares for signaling, and anti-personnel grenades to defend against infantry attacks. Since it was planned to act as a spearhead in breaking heavily defended enemy territories, the King Tiger was designed as a heavily armored vehicle. Its hull was built from hardened steel plates. The upper glacis plate was 5.9 inches thick and angled at 50 degrees, giving a relative thickness of 8.3 inches. During our research, we found no instance of the front upper plate armor being penetrated in a combat situation. Let us know in the comments if you know differently. The lower glacis plate was somewhat thinner, measuring 3.9 inches. It was also angled at 50 degrees. The upper and lower plates were joined together using interlocking joints to minimize weakness where the two plates met. The upper plate was significantly thinner, constructed from 1.57-inch steel. The front section featured a bolt-on plate with a vent and hatches for the driver and radio operator. Each hatch used a lift and rotate design, allowing it to be opened even by a wounded crew member. In front of the plate were periscopes for both the driver and radio operator. The driver's periscope could also rotate to a limited degree, providing a 100-degree field of view horizontally and 25 degrees vertically. The radio operator's periscope visibility was much more limited. Positioned at an angle and fixed in place, it provided only a 60-degree horizontal and a 10-degree vertical field of view. The front section of the floor was built using 1.57-inch steel plates to protect the driver and radio operator from landmines. The rear section plate was just 1 inch thick. The rear plate was constructed from 3.15-inch hardened steel. The hull's side plates featured the same armor. The front was the thickest part of the turret's armor, built from 7.1-inch thick steel and angled at 10 degrees to provide a relative thickness of 7.2 inches. The elongated gun mantlet, known as the Saukopf or pig's head, was specifically designed to be resistant to attacks and prevent shells from jamming the movement of the gun. Its maximum armor thickness was 5.9 inches. The sides and the rear of the turret were equipped with 3.15-inch armor. To rotate its heavily armored turret, the King Tiger utilized a hydraulic system powered by a pump connected directly to the tank's main engine through a drive shaft under the turret basket. This meant that the engine's rotational speed dictated the turret's rotational speed. With the engine running at 3,000 RPM, the turret could complete a full 360-degree rotation in less than 10 seconds. However, the rotation system was prone to malfunctions at such high speed. The standard full rotation time was 19 seconds, which would be achieved at an engine speed of 2,000 RPM. The turret's electrical systems were powered by the tank's main batteries, which were placed next to 2 of the 7 fuel tanks. The turret ring had a diameter of 72.8 inches. Its large size was necessary to provide a stable base for the turret and the gun. The entire design of the tank turret was largely influenced by the unique gun that it housed. The elongated shape of the King Tiger's turret was necessary to balance its unusually long cannon. The gun was mounted asymmetrically. This adjustment provided more space for the gunner without further increasing the already large turret size. The gunner was positioned to the left and controlled turret rotation using floor pedals and a backup lever located under his left arm. As he brought the aim closer to the target, he switched to a manual traverse system positioned between his legs for more precise aiming. For the gun's elevation, the gunner used a hand wheel located to his right. The elevation mechanism was assisted by compressed air from a compressor under the gunner's seat. When the system was active, the almost 2.5-ton gun could be raised and lowered with ease. Once the target was in sight, the gunner would release a lever on the turret rotation handle to lock the movement of the gun and hold the aim. An azimuth indicator was placed in front of him to prevent the gun from losing track of the turret's position relative to the tank hull. The azimuth was positioned so that it could also be seen by the tank commander seated right behind and above the gunner. The turret cupola had 7 periscopes arranged in a circle for a full 360-degree view. The commander's hatch could be opened by first turning a screw, then pushing a lever to fully open it. Once open, the hatch could be locked to prevent it from swinging shut while the tank was in motion. Opposite the gunner and commander was the loader's station. Although the loader had a retractable seat, he would usually stand during combat to load the gun. He had his own hatch and a periscope. The loader's station was equipped with an additional manual turret rotation handwheel, allowing the loader to assist the gunner with turret rotation when needed. Ammunition was stored in racks at the back of the turret and along the walls of the hull. This ready rack could hold up to 22 shells for fast reloading. 48 additional shells were stored along the hull walls for long-term storage. A standard loading procedure required the loader to take a round from the ready rack, lay it down on the roller, and load it into the gun chamber. After the gun breech was closed, the gun was ready to fire. A well-trained soldier could perform the entire operation in just 8 seconds. Some crews preferred to keep the ready rack empty out of fear of ammunition cook-offs, which could occur if the turret sides were penetrated. Keeping it empty also allowed access to the hatch at the rear of the turret. In an emergency, getting out of the top hatches would expose them to gunfire from all directions, whereas evacuating from the rear hatch gave some cover. To create an extra layer of protection for the ammunition inside the rack, links for spare tracks were placed on the outside of the turret. Tiger was powered by a 6-gallon V12 Maybach HL230 P30 petrol engine, sealed in a watertight compartment. This engine was very similar to the one installed in the Tiger I. However, cast iron was used for production instead of aluminum. This increased the engine's overall weight, but also increased its displacement by 1.6 litres, and thus its power. The Maybach HL230 could produce 700 horsepower at 3,000 RPM and 1,364.5 pound-feet of torque at 2,100 RPM. To prolong its lifespan, it was recommended to keep the RPM under 2,500. Theoretically, the tank could reach a top speed of 25.7 miles an hour on a clear road. In reality, its actual operational speed was limited to around 23.6 miles an hour. The engine featured a distinctive crankshaft design. Unlike standard crankshafts fitted with plain bearings and wings connected to the engine pistons, the Maybach HL230 had a tunnel crankshaft with rotary bearings. This design improved rigidity and allowed the pistons to sit closer together, creating a more compact and durable engine. The engine's 4 carburetors were fitted with air filters and drew air from a pair of armoured air intakes at the top of the engine deck on the access hatch. Further back was a third air intake. The King Tiger's Maybach HL230 was a gasoline engine, and the fuel for its operation was drawn from 7 interconnected tanks located within the hull. The tank connected to the filler cap was in the central rear section. Additionally, there were 2 tanks located in the sponsons, 2 at the bottom of the rear hull, and another 2 beneath the turret basket. Together, these tanks housed 227 gallons of gasoline. With an average consumption of just over 2 gallons per mile, it gave the King Tiger a range of 105.6 miles on roads and just 74.5 miles across rough terrain. 7 fuel tanks meant a maze of fuel lines connected the pumps that fueled the engine. That was another significant drawback of the King Tiger. With many couplings in hard-to-reach places, leaks were very difficult to detect, making fires a potentially serious hazard. To try and address this issue, the King Tiger was equipped with an innovative automatic fire extinguishing system. If the sensors detected temperatures above 120 degrees Celsius, the extinguisher would activate for 7 seconds. If the temperature remained high, the system would repeat the process. The engine was cooled by 4 radiators and 2 fans, separated into compartments on either side of the engine. The compartments were connected to the engine via a liquid coolant circulation system. A large crankshaft-driven fan was mounted between each pair of radiators and dissipated the heat. Since the fans were driven by the engine's rotational speed, when the engine's RPMs increased and the heat increased, the fans would compensate for that automatically. The King Tiger's engine could be started in several ways. The first was with the help of an electric starter. This option could only be used when the engine was warm. The second was the inertial method using a crankshaft, which could be operated 3 ways: by hand, with a rotary shaft from the engines of the Volkswagen Kugelwagen or Schwimmwagen, and using a gasoline-powered external starter. The driver controlled the tank with a special steering wheel, brake, accelerator, and clutch pedals. The steering wheel, an uncommon feature in tanks of the day, was connected to a steering box that adjusted the gear ratio for each track. When the wheel was turned, the track speeds would alter, enabling the tank to turn. The steering wheel was supplemented by a more traditional control lever for each track, providing a backup to the steering wheel. Pulling a single lever applied the brake to the corresponding track, causing the tank to turn in that direction. Pulling both levers brought the tank to a stop. Driving controls also included an instrument panel, a handbrake on the left side, a gear shift on the right, and a lever for switching between forward and reverse gears. The driver's seat could be elevated for driving with an open hatch, although in combat conditions, the driver would use a periscope. The King Tiger's drivetrain was arguably its weakest point. The components making up the King Tiger's drivetrain were credited with the most mechanical failures of any set of components. This was for one reason only: they were not designed for a tank of this weight. The King Tiger was intended to be fitted with a brand new drivetrain design that could be used both on the King Tiger and the Panther II. But when the Panther II project was scrapped, so was the development of most of the components it was designed to share with the King Tiger, leaving the King Tiger to be fitted with a drivetrain from the Tiger I, a tank 22,000 pounds lighter, and one that had already suffered reliability problems. The transmission used on the King Tiger was the Maybach Olvar OG40 1216B, with 8 forward gears and 4 reverse ones. Since the transmission was housed at the front of the tank and the engine at the rear, the two were connected with a multi-joint drive shaft running under the turret basket. The transmission system suffered from significant overheating and had to be encased in an additional thermal cover to protect the driver and the radio operator. The final drive system delivered power from the King Tiger's engine to the drive sprockets that drove the tracks. The sprocket teeth connecting the wheels to the tracks often bent under torque, and the interweaved road wheels made replacing the inner ones challenging. The final drive system was the most overstressed component of the drivetrain, and its failure rate was incredibly high. By the end of the war, the average lifespan of the system was just 186 miles. This meant the King Tiger could travel approximately 2 full fuel tanks before experiencing a final drive failure. The transverse torsion bar suspension system consisted of 9 load-carrying axles per side, each connected to a wheel supporting the tracks. This design allowed each wheel to move up and down independently. It also increased stiffness during turns, enhanced stability over rough terrain, and enabled higher speeds. The wheels were arranged in 2 rows on each side, so that every wheel partially overlapped the adjacent ones, increasing the contact area between the wheels and the tracks. This configuration helped distribute the tank's substantial weight evenly, reducing ground pressure and enhancing mobility over challenging terrains. For dampening, the King Tiger had a shock absorber on each corner, connected to the frontmost and rearmost set of road wheels. The idler wheel at the very back of each track was mounted on a pivot. Using a simple wrench, it could be moved to the rear to tighten the tracks and forward to loosen them. Crew interaction was crucial in combat. Each member was responsible for a different task, and their survival on the battlefield depended on how well they performed as a team.
Verdammt, ich kann ihn nicht sehen. Nehmt Stellung an der Straße.
The driver was responsible for delivering the tank to an advantageous position with a good overview of the area. Choosing a good position was crucial as it allowed the commander to locate nearby targets through the cupola periscopes. Upon locating the target, the commander gave the gunner coordinates and ordered the loader to load a specific shell type.
Ziel auf 11 Uhr, Entfernung 800 Meter, Panzergranate 39.
The gunner then rotated the turret towards the target's direction. Using the system of triangles in his sight, he determined the exact distance to the target and placed it on the tip of the triangle within the sight. The gunner and the loader had to loudly confirm that the target was acquired
Ziel erfasst.
and the shell loaded into the gun. With the gun locked on target, the gunner and the commander would check the light signals to see if the gun was ready to fire.
Feuer.
The shell would leave the gun at a speed of 1,090 yards per second. The precision and power of the King Tiger's gun was exceptional. Near L'Église in Belgium, King Tiger 204 spotted a Sherman at 1.27 miles range. The crew fired, and the shell struck the target's frontal armor on the first shot, sending the enemy tank into flame. The King Tiger was an extremely effective vehicle that dominated the battlefields of both the Eastern and Western fronts. However, even though armor and firepower helped win battles, logistics won the war, and the King Tiger was a terrible burden for German logistics. As one veteran of the 503rd Heavy Tank Battalion said,
1 hour of Tiger operation requires 10 hours of maintenance.
The infamous SS Panzer Division commander Joachim Peiper put his opinion of the King Tiger this way.
Of the great number of Panzers which are lost, 3 on 5 of them had to be abandoned and blown up. This is the fate of any mechanical failure and the curse of a continuous withdrawal. The race between armor and anti-tank gun has without a doubt been decided in favor of the latter. Therefore, it appears to me as senseless to go over a weight of 70 tons. More important than heavy armor are high speed and the covering of great distances. In my opinion, the development should center on these requirements.
But his demands were never met. The King Tigers suffered constant breakdowns, drank away all the fuel at a time of fuel scarcity, and their high weight limited mobility over bridges. They were so heavy that only special heavy tank rescue vehicles or other King Tigers could tow them in an emergency. On top of all its shortcomings, the King Tiger was very expensive to produce. The final cost of 321,500 Reichsmarks per unit. In rough estimates, this would amount to $2.8 million today. It cost twice as much as a Panther tank. All these things compounded at a time when Germany was unable to afford it, causing the armoured columns meant to spearhead the war to grind to a halt. We can only guess what this tank could have been if the German engineers had more time and resources. If you'd like to find out about a more obscure Nazi superweapon, then check out our video on the V3 London gun. Thank you for watching. This film was challenging to make, dissecting such a complex machine, and we still had to leave out many details. If you find any errors, please let us know in the comments. Thank you.